Hey guys, here are notes for section 10.3, surface area of prisms and cylinders. And I talked a little bit about surface area in class where I was talking about wrapping a present. The surface area is exactly how much wrapping paper you would need to cover your present completely. If this box represented your present, you would need to find the area of all the sides, not so that none of them are showing for it to be surface area. Prisms and cylinders, we're going to talk about them. So here are polyhedron is the first vocabulary term. A polyhedron is a solid that is bounded by polygons. Means it's surrounded by polygons. Now polygon we know is a closed figure that has all straight sides. No curved sides at all. No circles, no arcs, just straight sides. That's a polygon. And these polygons in a prism or in a polyhedron are called faces. So each side represents one face that enclose a single region of space. So they enclose something. It's another enclosed figure. There are no curves allowed in a polyhedron. Just like in a polygon, you cannot have curves. The figure must be closed and the faces must be polygons. All the faces must be polygons. Now a prism is a polyhedron because it does have all of this information. So it's a polyhedron, but what it does have, it has two congruent parallel bases. So it has two congruent parallel bases. The remaining faces are all called lateral faces. So like the exact two that you could do this square right here and the other square at the other side would be the two bases, and all the rest of them would be the lateral faces. A lateral face are parallelograms. They're all going to be parallelograms. They're going to have parallel sides that share an edge with each of the bases. So you can see that this parallelogram right here on top touches this base and it touches this base. So basically what they do is they connect the bases. A lateral face is going to connect the two bases together. That's what the lateral faces do. Now the height is always from a 90-degree angle. So you can see the 90-degree angle. So my height can be right here between my two bases. My height is going to be at a 90-degree angle from the base. The slant height is not at a 90-degree angle. So you can see that this right here is not 90 degrees. That's acute angle. So this red line is not a height. Now if the lateral faces are perpendicular to the bases like you see here, if this base and this face and this face is perpendicular, then we have what we call a right prism because we have right angles. Right angles makes a right prism. If you don't have perpendicular bases, then you have what we call an oblique prism, where you have angles that are obtuse or acute. They're not right angles, so that'd be an oblique prism. Let's label some of these sides. This right here we would call a lateral face. This right here we could call a base because we have two of those. And here's our other base right here. Notice how this top triangle and this bottom triangle are also bases. It just says they have to be polygons. They don't have to be squares. They could be any shape. They could be hexagons, pentagons. You could have all kinds of prisms. You just have to have two congruent parallel bases. So a triangle parallel to a triangle, and they're both congruent, would be bases. This down here, these would be lateral faces. This face right here and this face right here would be lateral. This one right here we would call the height because it's at a 90-degree angle. This over here would be called the slant height because it's not at a 90-degree angle. That'd be our slant height. And you can pause the video if you need to. Okay, one way to find the lateral area and the surface area is to unfold the prism to form a net. Now we did do this in class a little bit today, so you have seen one of these. Here's our rectangular prism. If you cut one side and then you unfold it, it would look like this. You'd have your top and bottom, which would be these two right here. You'd have your sides, which would be the other two. And then you'd have your two bases, which would be the two squares here at the end. Those would be the two bases. So the lateral area of this net, so this might be easier for us to find the surface area. We could just find the area of all the sides and add them together. So this area right here is this is the top. Sorry, that's not what I wanted. Hold on. What I really wanted was a number. Okay, so this is 50. This is a 10 by a 5. These light blue lines are all 5s. So this is a 10 by a 5 right here. This one is 60 because it's a 10 and a 6 because all the purple lines are all 6s. So that's 60. This one down here is 50 again. It's a 10 by a 5. And then this one down here is a 60. It's a 6 by a 10. So that would be a 60. And then if you add all of those lateral faces together, you get 220 square meters. So 50 plus 60 plus 50 plus 60 gave you the 220. So those are that's my lateral area. The area of my bases would be 30 and 30 because this right here would be 30 because it's a 5 times a 6. And this one over here would also be 30 because it's a 5 times a 6. So 30 plus 30 would be 60. So my entire surface area is 220 plus 60. I get 280 square meters. Would be my entire surface area. Now the question is there an easier way or a formula to find the surface area, or do we have to label all 4 sides or all 6 sides and add them all together? Now you can always do this. It's not wrong. You will always still get the surface area as long as you remember to do all 6 sides or however many sides it has. But there is an easier way. There is a formula that we could use. So let's first find the perimeter of my base. Let's add up 4 sides of this base right here, this little rectangle. 5 plus 6 plus 5 plus 6, which is also 5 plus 6 plus 5 plus 6. It's also the long side of this big rectangle. So I could basically just find this rectangle, be doing 10 times whatever this is, which is 22. So 10 times 22, 10 or times the height 10 gives the area of the big rectangle, which is the area of the lateral faces. So your lateral faces are basically 10 times 22, because this whole thing adds up to 22. So 10 times 22 is 220 right in here. That's this number that we already got. And then if we add that to the area of the 2 bases, 2 times the 30, you've got 2 30s here, so you got 60. So 220 plus 60 gives you 280. So there is a shortcut formula, and if you know the formula, you don't have to go through all of this stuff. If you know the formula, you've got this right here. The surface area, which that's what S equals, equals the lateral area plus the area of the 2 bases. So my lateral area, to get the lateral area, we did the perimeter of the base and we multiplied it by the height. That's the 220. So to get the lateral area, we could do the perimeter of the base and then we times it by the height. That'll get me the lateral area. Put that in there so you can see that. Right here, lateral area. That's not going to do a white arrow on a white background. It's not going to show up. Okay, so the lateral area would be the perimeter of the base. So we took the perimeter of this base, 5 plus 6 plus 5 plus 6. Take that amount, which was 22, and times it by 10, the height. So the perimeter of the base times the height. And that was the lateral area. Then we added it to the 2 bases, because we had a 30 here and we had a 30 here, so we had 2 30s, 2 bases. So that's just a little shortcut. So let's apply this formula to an example here. Find the area of this prism. It's got a 3, an 8, and a 5. So let's see how it looks. We know the formula is right here. So we have 2 times the area of the base plus the perimeter of the base times the height. Remember I said the 2b, or to get the lateral area, the L, you do the perimeter of the base times the height. So what we're going to do is your S is your surface area, your P is your perimeter of the base, your B is the area of the base, and the H is the height. So we would want to solve this right here. So let's see what we would get. We would have, let's see, 2 times the area of the base. So let's make our base the front and the back. So 3 times 8. So it's going to be S equals Make this bigger so you guys can see it. S equals 2 times the area of the base, which is going to be 8 times 3, plus the perimeter of the base. Base would be 3 plus 8 is 11, plus another 3 and 8 is another 11. 11 plus 11 is going to be 22 is the perimeter of the base, times the height, which is 5. So our surface area equals 24 times 2, which is 48, plus 22 times 5 is 110. So 48 plus 110, you're going to get 158. And that would be square inches. Surface area still has area in it, so we know it's still going to be square inches. So there is your surface area of this prism right there, using this little formula. So we didn't have to go through counting all 6 sides. We can just plug it into this formula and get our answer a little bit quicker. Okay, cylinders. Now a cylinder is a 3-dimensional solid with 2 congruent circular bases. Kind of sounds familiar. Prisms also had 2 congruent bases, but they were not circles. Prisms have to have polygons. Cylinders have to have circles for their bases. So just picture a Pringles can or an oatmeal carton. Those are cylinders. It's almost the same formula, with the bases being circles and the perimeter changing to circumference. So instead of finding the area of the 2 bases using the length times width, we're going to use the pi r squared for the area of the bases because it's a circle. And we're going to be using 2 pi r to get the circumference instead of the perimeter. So surface area of a cylinder, the B stands for the area of the base, which are the 2 circles. The C stands for the circumference of the base. That's going to be the 2 pi r. And the H, of course, is the height. And the height is always in between the 2 bases. The formula here, you've got 2, and then you've got the big B, which is pi r squared. You've got the big C, which is 2 pi r, that's circumference, and then times height. So this is the area of the 2 bases, and this is the lateral area. So all the way around it, plus the 2 bases, you get your whole surface area. So that's the formula for surface area of a cylinder. You just need to find out how much to cover the 2 bases, then you need to find out how much to cover the whole sides. So that's what you did here. Here's the area of the 2 bases, here's the area of the whole rest of the sides. Okay, it might help to see a net of a cylinder. Remember, a net is something we unfold and see what it really looks like. Your lateral area is still a rectangle. If you cut the cylinder so that you've got your 2 circular bases, and you're going to have a rectangle still. So you're still going to need the length of this, which is actually the circumference of your circle, times the height. So you still need to get, or you can see that you still need to add the area of the 2 bases to get the lateral area. You need to get you can see that we still need to add the area of the 2 bases to the lateral area. So add the 2 bases to this lateral area and it gives you the surface area. So if we wanted to find the surface area for this cylinder, we would use our formula, 2 times B, 2 bases, because you get 2 circles, the circumference, which is the 2 pi r, times the height. So you just plug it in. You get your 2 times your pi r squared. The area of the base would be pi times 3 squared. Circumference is 2 times pi times radius, or 2 pi 3, and then your height is 4. And then you plug in the numbers and you get your surface area of 131.9. This is all calculator work. Once you can get this formula, it's home free. You just put it all into your calculator. Alright, so let's try one. Find the height of a cylinder. Okay, this time is a little different. This time they want us to find the height. But they gave us the surface area. So we're still going to use this formula right here. Same formula, except this time we have S. So this time I'm going to put in S. Put in 2, put in pi r squared for B, put in 2 pi r for C. Only thing I don't have is the H. We're missing the H. So I plug everything else in, and then it's all calculator work. This comes down. This right here multiplies in my calculator. I can do this 6.5 squared, then I times it by pi. Then I times it by 2, I get 265.5. 2 times pi times 6.5 gives me 40.8. Then I'm going to subtract the 265.5 on both sides. Then I'm going to divide by 40.8, and you're going to get roughly 8. It's going to be like 8.00 something. So your height is approximately 8. Alright, that is it for notes. Here are your practice problems. On the first two here, make sure you draw a picture over here. It will help you. You got your perimeter, your base perimeter of 5 and your height of 2. You should be able to figure that out. And then a right cylinder, you can just figure that out. You've got these two to find the surface area of these two. Now this one's a little tricky. Find the whole, so you're going to need to find the surface area of both prisms because you need to cover up the outside and you need to cover up that inside stuff. So find the surface area of both. You're going to need to subtract out this little, actually you can just subtract out the squares. You don't have to do the surface area inside. Just subtract out the little squares. And then your last, oh, that's it. All right, we will see you guys tomorrow.